Hi everyone, in this video we are revisiting the surface to truss component, but this time I'll be focusing on some quirks which you may encounter when generating trusses from different types of surfaces. Just as a quick refresher, the surface to truss component takes a surface input and turns it into a truss structure. You can choose between various truss types, subdivision counts, and other parameters. If you're new to this component, you can check out our introduction video linked below. Now, there's one common issue that arises when we use trimmed or planar surfaces created from closed curves. In this case, I drew a closed curve in Rhino and created the surface using planar surface. I referenced it in Grasshopper and plugged it into the surface to truss component. Instead of getting a curved truss as intended, I get a rectangular result instead. And this is why it happens. I've got a trimmed surface that's been cut using trimming curves to define the visible and hidden areas. While the underlying untrimmed geometry remains unchanged, if you were to use the untrim command in Rhino, you would see this underlying geometry. The component ignores this visual trim and generates the truss on the untrimmed surface. This leads to a rectangular truss even if your surface looks like an arch. If you want to avoid this, one solution is to generate your surface using a loft between two curves, an arched curve and a straight line. This creates a single untrimmed surface. As a result, the truss is generated correctly. The top chord follows the arch and the bottom chord aligns with the base curve. And with this method, surface to truss reads the input geometry as intended. Another thing to keep in mind when you construct arched trusses like this one, or triangular trusses for example, is that the first and last top beams of the truss will overlap with the first left diagonal and the last right diagonal. Therefore, the result will have duplicate lines in these positions. These lines should be called out of the model afterwards, and I've done so here in this cluster. One more feature I would like to talk about is a dynamic relaxation input. This attribute adapts the position of the cells so that the angles are as large as possible and therefore creates more regular diagonals. To see this better, let's look at a simple rectangular surface. After adding the surface to Grasshopper, the generated truss is clean and well structured. However, once I begin to modify the control points of the surface, the truss geometry responds accordingly by producing irregular triangular patterns. When I enable dynamic relaxation, the component repositions the nodes in the way that smooths out these irregularities and restores a more even truss geometry. Thank you and see you at the next video.